Right, let's now investigate the integral, the area rather, between a line and a curve like we have here. Okay, and let me start by posing this question. How would you work out this area? I'll give you 2 minutes, a minute or two to discuss it in pairs, and then we'll go over your responses. Off you go. Right, so how would you work it out? What do we have? What suggestions do you have? Wisdom.
Maybe equate the two equations.
Equate the two equations, okay, and then what?
Find the integral, find the area that way.
Find the integral. So if you make x squared take away 4x plus 5 equals x plus 5. So what you say? So you're equating the two and then doing what? Find the y-axis. Find out what x. So if you solve that, that will give you, in terms of the geometry on the graph, what's that going to give you? Sorry? Points of intersection. Okay, so let's call this x1. Let's call this x2. So that, yeah, clearly you can see what's going to happen. You've got a simultaneous equation. When you equate the two and you solve it, you end up with their points of intersection. Okay, what would you then do with that? How then do you find that area?
Do you integrate the curve and then use those points, and then you integrate the line,
Yeah,
and then you use those points, and then you take them away?
excellent. Okay, so what Temi has suggested is essentially, if I put it in terms of diagrams, guys, is essentially something like this. If I take this area, which is the area underneath the line, and I was to take this area, which is the area underneath the curve, correct? If I subtract them, we're left with this area, which is the area bounded by the line of the curve. Do you agree? Yeah? So essentially this would just be the area of x plus 5 dx, take away x squared, take away 4x plus 5 dx, and then that will give you the bounded part of the area. Now the limits will be what though? What would your limits be? Yes?
0 to 5.
0 to 5. Why is it 0 to 5?
Because that's where the area starts and finishes.
Right, so yeah, essentially the points of intersection, isn't it? It's what we've established as x1 and x2, where these are our points. I'll put this out. These are our points of intersection. Yeah? And that's what we get. Right, what I'd like you to do is actually have a go at doing that and see what you end up with. Okay? I'll give you a couple of minutes. Off you go. Let's go over it. So we should have got 20.83. If I just use this and just give you the outline of the answer. So we should have got, I'll write this down here, 20.83 reoccurring. So if we break our integral down into two parts, okay, what do we get for the first one? So if I just write this down as A1 take away A2, yeah, where obviously the first integral is A1. What do you get for A1? 37.5. Is that right? What are your points of intersection, by the way?
5 and
0 and 5. Okay.
Yeah.
0 and 5. Okay. So you've got that point of intersection. What about your second one? What's your A2? 50 over 3. Everyone agree with that?
Yeah.
And so 37.5 take away 50 over 3. Wisdom, what does that give you? Sorry? Did you double check these values? 20.83. Okay. Everyone happy with that? Sabiha, is that okay? Alright. Let's now turn the question on its head. And let me do this. Okay, let me do this same thing, but I'm going to sort of bring a little sting in the tail, as one of my lecturers used to call them. But here, so I'm going to do this to it. We've got this equation here. We've got this straight line here. The value is 20.83. That is the answer. Okay, but how would you work out the equation of, how would you work out the area bounded by this curve? Bearing in mind, we said when you integrate below the curve, the integral gives you a negative value, but obviously the area is always positive. So how would you work this out? I'll give you a minute to think about it, and then we'll go for it. Off you go. Now, one suggestion is, yes, we can work out the region below the x-axis and the region above the x-axis separately. Okay, and then you know, it might be a bit tedious to work out A2. I guess you've got to work out A1 first. But let's have a little think about this. Here's GeoGebra, okay, and here I've just plotted this function, x squared minus 4x plus 2 and x plus 2, okay, and we're looking for this bounded region between the line and the curve. Okay. Now let me ask you a question. If I were to take fx and move it up by 10, okay, and then I take gx and move it up by 10 as well. Okay, so we get the orange and the blue line. Would you agree the bounded region is essentially the same? Doesn't make a difference.
Yeah.
It's the same, isn't it? Okay. And so if I rewrite the problem as hx and px, i.e. I've taken fx added 10, taken gx added 10, I've created a new problem. But the area is always going to be the same. If you add a constant, it's got everything below the x-axis has gone above, and so it's essentially the same problem, isn't it? Okay. And so if I work out this area, and we know how to do that, it's a line take away the curve. Okay, then that gives me the correct area. Do you agree? Okay, but why does that work? The reason why it works is as follows. If you think about this, firstly, if I just write down the bounded area equals the integral of the function, I'm going to write down function because it could be a line or a curve, above, take away the function below. I'll write dx here and just put down points of intersection x2 and x1. So I'll just put down points of intersection, okay, between these two functions. And that's what we found so far. Okay, and what that means is that I could have this scenario, or I could have this scenario. By extension, I could even have something like this, where there's two curves. Okay, but which one's above in this case? The line. Which one's above in this case? The curve. Which one's above? Well, one of the curves is above. So you get the idea. It's always the function above, take away the function below. And the reason is you can understand that because in this case, what you're basically doing is, if you visualize it geometrically, you're basically doing this region subtracted by this region gives you this bounded region. That's essentially what we're doing. Alright, let's now go back to our GeoGebra example. Maybe I should put it in here just as part of your notes. Somebody's going to look back at this later on. I'll take a little snapshot and let's do something like this. Okay. Alright. Now let's just think about what's going on here. I've got fx, okay, and we add c to it. Oops, we add c, fx plus c. Take away gx plus c. Is that correct? Yeah. All I've done is added some constant c. In this case, it was 10. We just moved both of them up. Now, one of the things we can do is actually, because they're both with respect to x, if they have the same limits, if I've got x2, x2, x1, x1, I can, if I want to, write them as a single integral. I can just write down x1, x2, and simply write down fx plus c, take away gx plus c, dx. That's fine, as long as you've got the same limits. Now, I'll make a point of that. I'll write down same limits, therefore one integral. Okay? So we've taken both of them. Now, what's going to happen to the c? It cancels out. C take away c. So you end up with fx, that should be in bracket, fx take away gx dx. So that means if you've moved it up by 10, does it make a difference? It doesn't. So what you could do, in order, if you go back to the question, listen to this very carefully, all you need to do is just integrate this like you normally would. You just do the line take away the curve. Agree? And whether the region is below the x-axis doesn't make a difference. And if you're not convinced, then move it up by 10 or 100 or million. Subtract the two. The millions or the 10 or 100, whatever you're adding, is going to cancel out anyway. And you're left with this problem, which you do anyway. Okay, so in this case, funny enough, the fact that it's below the x-axis doesn't make a difference. You can simply invoke the rule that I wrote down earlier over here. Let me just make that a bit big so you can see it. Where the bounded region is a function above, take away the function below. Is that okay? Alright, does anybody want to copy parts of that down? I'll give you a minute or so just to copy down what you want, and I'll give you some questions to then get on with. The main part is just make sure you've got this part down, where you've got the bounded region is the bounded area is a function above, take away the function below. Okay, so you've got this formula down.